Hello, so thank you very much everyone for dialing on. Welcome to one of our webinars. I'm going to hand you over to Andy Parkin and then we'll get it going.
Right, well, morning everyone. Thank you for joining us. My name's Andy Parkin. I'm a partner at Cundall, and we're going to be talking this morning about clean air zones. Something that you've probably heard about to a greater or lesser extent, depending on what city that you live in. But we're going to be talking about them this morning and what the implications are, not just what the specifics are, but what it means and what things may come out of them as well. So for those of you who are wondering who on earth is going to be talking to you, this is us. This is the order that we're going to be taking the main subject through with. So my colleague Jenny Carrington from our air quality team, myself, I'm going to talk about the noise aspects, Glyn Hodgkiss from the air quality team, and then Neil McAlpine from our transportation team. So we're going to be delivering the talk to you this morning. So the things we're going to talk about are, now we've got you as a captive audience, I'll tell you a bit about Cundall. Then we're going to introduce the concept of clean air zones. What are they all for? Then what are the noise impacts? Some more information about the air quality and the transportation, and then we'll wrap things up, and then we have time at the end for questions and answers. So just to tell you a bit about Cundall, if you don't know already, we're a global consultancy in the built environment. We've been around for over 40 years. We're mostly still all working from home, but we do that in a very connected way. We are looking forward to going back into our offices and seeing our colleagues again, but we just have to be patient with that. One of the key things is our take on sustainability, and we're going to talk a bit about that because that really underpins everything that we're talking about this morning. We have offices all over the world, and we operate on projects all over the world as well. Now, I'm very mindful that what we're talking about today is quite a UK thing. But the principles will apply wherever we are, and I'm not sure what the reach of clean air zones or the equivalent is outside of the UK, but it's something which is applicable to everywhere. One of the things that we're very proud about is that we have achieved net zero carbon status. We've been classified as carbon neutral by the Carbon Trust, and there's a lot to do with this in the talk about clean air zones. And when we look at the steps to achieving net zero carbon, so many of these things come into play when we're talking about the clean air zones and people who live, work and go into clean air zones. We've got passive design, we've got operational energy, fossil fuels. All of these things really come into play, and they're a major consideration when we're looking at clean air zones and why we're having them. And this is something that we feel very passionately about. We don't see there's any other choice. We have to aim for net zero carbon in everything that we do. And we're pleased that we can lead the way in that. And we would urge you all to go the same way. And if you need any assistance in how you or your clients or your building stock can achieve net zero carbon, then please get in touch with us. We're very proud of the work that we do. We win lots of awards and for all different things, not just to do with environmental, but for building design and everything. We're very proud of what we do, and we take a lot of opportunity to celebrate with our clients and staff the difference that we can make in the built environment. And we operate across a number of sectors and services, and the particular ones that we're going to be dealing with today are air quality, acoustics and noise, and transportation. But all the other ones here come into play, and we work with our colleagues. And the reason we're doing this seminar as a joined up approach is because that's how we do things. Clean air zones are not just about air quality. They're not just about transportation. They're about everything. And one of the key things is that there are consequences and knock-on effects for everything and everyone that we work with. And generally, clean air zones tend to be in the city centres, and therefore most of these things will come into play, most of these sectors. So I'm going to hand you over to Jenny, who's going to talk to us about what clean air zones are. Jenny.
Thank you, Andy. So why clean air zones? So it's well known that poor air quality has a significant effect on public health, both in the long term and the short term. Great, sorry, my buttons, there we go. So why clean air zones? So air pollution comes from a number of different sources. So as well as transport emissions and road transport and non-transport, there's also industry, agriculture, residential and commercial small-scale combustion. But for road transport, DEFRA has estimated that about 80% of NOx emissions come from road transport, with the largest source being diesel light-duty vehicles and cars. So to enable compliance with the nitrogen dioxide objective, a clean air zone could be an appropriate way to go based on the results of modelling for the UK's Air Quality Action Plan. There we go. So what is a clean air zone? So it's an area where targeted action is taken to improve air quality by discouraging the most polluting vehicles from entering the zone. So the aim being to reduce air pollution associated with road transport, such as nitrogen dioxide and particulate matter. So there's different types of clean air zone, non-charging clean air zones. So this could be pedestrianised zones, restricting vehicles in that area, or allowing vehicles in but a charging structure. And there's 4 different classes, A, B, C and D, as you can see there, that with each that there's an additional scale of so with D being all encompassing. So the cars included there would be Euro 6 diesel and Euro 4 petrol or lower. And another term for a charging clean air zone is a low emission zone. So how are we getting on with the clean air implementation? So there has been somewhat of a delay with COVID, and some of the dates have been postponed or are still up in the air. York is proposed to be the first to go ahead in January next year, and it's going to be the first voluntary clean air zone in the country. And includes one of the measures is request for funding for zero carbon vehicle delivery, including the use of rickshaws, which I think is a great additional level of innovation there, really. And I know they've been in use in Edinburgh for quite a while. The ultra low emission zone in London is due to expand in sometime in 2021 to the north and south, and Birmingham and Bath and Greater Manchester already have confirmed dates, but the dates for Newcastle and Gateshead and Sheffield are still up for confirmation. And there's other cities where a clean air zone is still to be considered further. So this might be based on feasibility studying to determine whether this clean air zone would actually be appropriate and deliver what is needed to enable compliance. I'll just caveat that some of this is ongoing investigation and discussion. So it may be that there may be an update on this list here or something's missing. So how effective is clean air zone implementation? So an example of the ultra low emission zone in London from the period when it started, in the start of 2017 up till February 20. So you can see the bottom 2 lines are the inner London area. So there's been a very low, marginal change in nitrogen dioxide concentrations, but the upper 2 shows central London, the area of the ultra low emission zone, and you can see that there has been a marked reduction in nitrogen dioxide. So will the CAS be sufficient? Well, the CAS-D, that's the most encompassing with vehicles, outperforms the other CAS options, which would be to be expected. And CASC has shown a more limited improvement. There is limited potential from improving PM 2.5, as this is not just related to emissions from brake but also from brake and tyre wear. So it may be that the implementation of additional measures may be required to enable compliance with the limit values. So what measures could be in addition to a clean air zone? So network interventions such as one-way schemes, banning of right turns, speed restrictions, and revising parking fees to discourage parking in city centres, and improvements to the public transport and pricing, and as well as improvements to the taxi and bus fleet. So there are some cities that have decided not to implement a clean air zone, including those that were originally first mandated, which were Derby, Nottingham and Leeds. So the justification may be based on feasibility studies that demonstrate that additional measures would be sufficient to enable compliance. This might be the measures that have already been taken to improve the bus fleet in the city, as well as other transport-related measures. So how has COVID behavioural change impacted on all of this? So you can see that this graph is taken from Department of Transport data from up to November, so fairly recently from the start of lockdown. So at the top, you can see that cycling had a massive increase of up to nearly 400%, but it's gone back down. So there really needs to be a shift from recreational cycling to commuter cycling. One of the ways that this could be achieved is ideally is improving the cycling infrastructure, and there could be an opportunity for this in new planning of new developments. The bottom line, so the goods vehicles, heavy goods vehicles and light goods vehicles, there was an initial reduction, but they've crept back up and may even be slightly above pre-COVID. Perhaps to do with more of online and at-home shopping. But the public transport lines at the back, they're still a lot lower than pre-COVID. This is probably to do with the risks, concern of travelling on public transport at the moment. And this needs to be promoting a public transport, and to suggest that this will be okay. So I'm going to thank you. I'm going to hand over to Andy now. I was going to talk to you about acoustics. Thank you.
Okay, thanks, Jenny. I think the key message there is that the clean air zones are to try and reduce and change the traffic that are going on in central cities. Now, a lot of people live in central cities as well as working in central cities. So what impact does this have? Because we know that for each action, there is an equal and opposite reaction. So when we change the nature of the vehicles, then what does that have as an impact on the people living and working within these clean air zones? So we've talked about things like NOx, nitrogen monoxide, nitrogen dioxide, PM 2.5, all the dust that comes off brake pads and diesel particulates. But what about noise? Well, surely if there's less traffic, then there's less noise, and that's a good thing. Surely. Well, yes, if that's as simple as it is, then that's the case. But let's just think about this a bit. So on the basis of the number of people stay the same, if people continue commuting, then if they're not traveling within the central zone, then they're still traveling somewhere else. That's pretty logical, really. So what's happened in London is that people have avoided the central zone and just commuted to, say, the stations on the periphery and then travelled in. So what that's doing is if the numbers of cars and the number of vehicles stay the same, it's just pushing the noise elsewhere. So the city centres may get quieter, but the suburbs may get noisier, especially areas around trains and bus routes. So there are unintended consequences of that. But there's no two ways about it. Diesel and petrol cars are noisy. And the reason they're noisy is because the engine gives off noise. The exhaust is a source of noise, and the tyres are a source of noise as well. So you've got those 3 key points of interaction. But you look at that compared with electric vehicles, because the idea is electric vehicles are quieter because they don't have noisy engines. Well, maybe, but they're not silent either, because they still whine, they have a motor. It's just a different type of noise. And the thing that there's no different between electric vehicles and petrol and diesel vehicles is the tyre interaction on the road. Now, when it's dry, the electric vehicles will be quieter, but when it's wet, there'll be absolutely no difference, because when it's wet, what you hear is the tyre noise in the rain. So that doesn't actually change. And when we're looking at how we cut out noise as well, generally the higher the frequencies, the swishing, the hissing noises are easier to get rid of by a closed window than engine noise. So in that respect, it should be easier to get rid of that noise. But if you're using trickle vents for ventilation, as a lot of residential apartments and houses do, then that lets in a lot of high frequency noise. So it may not be as straightforward as we think. The other thing is that if we have less congestion, then that means that the traffic that is there can move more freely. And that means that people are accelerating and decelerating quicker to and from junctions, and therefore that could be just as noisy. Anecdotal evidence from places like the M6 the dreaded M6 M5 junction near Birmingham it's actually quietest when there's a traffic jam. It's when the cars and when the traffic is all moving that it's noisiest. And so things will be different. They may not necessarily be quieter. There is another aspect of pedestrian safety in electric cars as well. With a diesel car or a petrol car, you will hear them coming if you're not paying attention. With an electric car, if it's driving in low speeds and in dry weather, you may not hear it coming, and therefore pedestrian safety is something that needs to be looked at. And that's led to a lot of car manufacturers looking at how they can synthesize noise to put back into cars, so you can hear them coming. So it's a different science in itself, really. But one of the things that we've talked about previously in our seminars is residential overheating, and I think it looks as though clean air zones should have a net positive impact on this, because if we're decreasing the amount of traffic in our city centres, or having them moving faster, then that should have a beneficial impact on how we can control overheating in people's houses. Generally, unless we have comfort cooling in apartments or houses, then we rely on the opening windows for that air change. And the wider we open the windows, the more noise comes in. It's quite obvious, really. But also, we talked earlier about how trickle vents allow a lot of the high frequency, the hissing noise through. And that's the same principle, that if you've got a small opening, then you get a lot more high frequency noise. So just by cracking the window open slightly, you will still get a lot of that high frequency noise coming in. But the overall noise level inside will get higher the more often and the more wide you open the windows. So if we can make city centres quieter, then that means that alleviation of overheating will not have as much of a noise problem. But what we need to do, thinking about the carbon aspect of this, is that there's a general push to decarbonise as much as we can. So if we can avoid the need to comfort cool building stock that would have otherwise been comfort cooled, then that can only be a good thing, because generally the only way of comfort cooling is by adding in putting cooling energy in there, which generally unless there's a lot of solar or wind energy used for it, will require fossil fuels. And so if we reduce the amount of plant, then we reduce the amount of power, and that's something that Neil's going to pick up on a bit later, is the energy demand in city centres. So I'll pass you over to Glyn, who's going to talk about air quality.
Good morning, everybody. Thanks for tuning into today's webinar. So in my section, I'll be picking up on some of the issues raised by Jenny, talking a little bit more about some of the uncertainties surrounding the rollout of clean air zones in future, how these could potentially impact on future air quality, and how all of this affects the thinking around building design, specifically building ventilation. So this slide summarizes some of the trends that Jenny talked us through earlier. It relates to the first 10-month reports for the ultra low emission zone published by the Greater London Authority. So it covers the period up until April of this year when we had the first lockdown. So the first thing to note is that right in the centre of London, at the heart of the ultra low emission zone, we saw a 44% reduction in nitrogen dioxide or NO2 levels. Also, to a lesser extent, we saw improvements as far as the outer London zone, albeit at a reduced 20% figure. This has been brought about largely by a reduction of 17,400 non-compliant vehicles from the ultra-low emission zone area. And if you think about it, putting these vehicles side to side, you'd probably have a traffic jam stretching about 48 miles. So that's kind of adds a little bit of context to the kind of height of this achievement, really. We've got other emission reductions too, 6 tonnes of PM2.5. That's roughly the weight of 3 London cabs. In percentage terms, only 15%, not as impressive as the NO2 reduction, reasons for which Jenny has already mentioned. And then finally, we've got this 12,300 tonne reduction of carbon dioxide. That's the equivalent kind of volume to 23 buildings the size of the Gherkin, again, to give a little bit of context there. So it's important to remember that these emission reductions are all at the tailpipe of the vehicle. And if we think about potential clean air improvements that all of this is going to deliver in future, obviously there's going to be a capacity for much greater levels of natural ventilation, potentially within the building design. So this is going to continue to give massive CO2 savings as we move forward. Now, London is in a pretty unique situation because the costs associated with the health aspects of the air quality impacts are the highest in Europe. So London has probably the most to gain. And in the period leading up to the first lockdown, the economic situation was good enough to support this 50% reduction in non-compliant vehicles. So if we roll some of these clean air zones out in future after COVID, are we going to expect similar reductions in other areas of the UK? So obviously a lot has changed since this data was collated. And expanding on some of the points that Jenny mentioned earlier, we've obviously seen only a 50% return in some modes of public transport, obviously fueled by security concerns, social distancing, etc. But there's a concern that if we don't return to full pre-COVID levels of transport usage, this could have a detrimental impact on vehicle numbers on the road. Obviously, many local businesses have been devastated. Personal finances have been devastated by job losses. This is all going to impact on people's ability to fund cleaner vehicles, even if they were in a position to do so. So this is going to decelerate uptake of low emission vehicles into the national fleet. And then the final consideration is one of increased levels of home working. Obviously, this has helped to improve levels of traffic on the road. But if you think about the additional combustion of fossil fuels resulting from increased energy usage and home working, this could have a detrimental impact on background emissions. So what I'm trying to say here is that, just bear with me a second. Okay, so all of these factors are important because they all feed into the thinking around the design of clean air zones. So the kind of things that you'd consider at the planning stage, spatial extent of the area, types of vehicles to target, timescales for implementation, etc. So it's important that we can scientifically examine all of these variables in producing a technical case to support the implementation of the clean air zone. And in order to do this, we use something called air quality dispersion modelling, which we can use to predict future air quality concentrations. And we can play around with various variables such as the targeted vehicle classes, various charging rates, to arrive at an optimum solution in terms of delivering value for money, maximum air quality and health benefits. But the issue is that obviously during COVID, all of these variables have been thrown up into the air, and we will have a new normal situation where we potentially need to re-examine some of these issues in the light of latest evidence. Could you just hit next slide for me, please, Andy? Thank you. Okay, final layer of uncertainties that we need to consider. Will the business case stack up once all of these new variables have been re-evaluated? We've got the Brexit situation, impact on national legislation. The Environment Bill is currently going through the Houses of Parliament at the moment. It's possible that we'll be seeing new PM 2.5 standards in future. Will these be the same as they are now? Will they be more aspirational? If this is the case, then this obviously acts as a driver for further clean air zone policy. Jenny's already touched on additional measures. These are often needed to support the CAS to make sure it delivers maximum benefits. And sometimes we need to possibly think that implementation of additional measures alone could be enough to deliver the requisite air quality improvements. And this is why some of our areas have decided not to implement the CASs, as Jenny touched on earlier. And then finally, we've seen some pretty drastic air quality improvements nationally and internationally throughout lockdown. The thinking in the industry is that these are going to be temporary and short-lived, but if traffic levels don't return to pre-COVID levels, then there could be some benefits that we could see benefiting air quality here. Given all the above uncertainties, how do these layer upon layer of uncertainties affect our general thinking and the strategy that we take in terms of building design? So, Cundall's approach is based upon a robust long-term strategy. We feel that this is essential in contributing towards good building design. We need to think about optimizing opportunities for public health protection, also whilst keeping one eye on the on achieving excellence in sustainable design and reducing dependence on over-engineered ventilation systems. The other thing that we need to think about is, do we design our buildings to achieve regulatory compliance, that is compliance with current air quality standards, which are used and adopted by planning authorities? Or do we go a stage further and try and achieve better internal air quality standards by trying to achieve best practice guidelines suggested by the World Health Organization. And you can see here that they have tighter standards for PM10 and PM2.5. So all of this creates a bit of an ethical environmental dilemma, if you like. We need to try and achieve public protection. This means reducing levels of natural ventilation in buildings, in areas of poor air quality, but increasing the dependence on engineering. Obviously, we're pushing up our energy and operational costs. So all of this forces us to take a conservative approach in terms of our assessments, certainly for protecting public health. There's often a school of thought which says, well, okay, if we've overestimated the air quality impacts, we could be over-engineering our design solutions. So we found additional monitoring is quite a useful tool in terms of trying to demonstrate, if you like, that air quality may not be as bad as first predicted. And this gives us the opportunity to introduce more natural ventilation as part of the development design. Next slide, please, Andy. Okay, so this is a case study from a recent project that we've been working on. It's a 1,200 apartment student residence in Selly Oak. It lies approximately 3.8 kilometres to the southwest of the proposed clean air zone air boundary. So the development will not benefit from the maximum air quality improvements delivered by the CAS. But nevertheless, modelling has predicted that we could still see improvements of up to 0.8 micrograms per cubic metre NO2 in the Selly Oak area. But as part of our assessment, we ignored all of these potential improvements. We assumed that the CAS would not operate in future. We assumed there would be no improvement in background concentrations and vehicle emission rates, and we assumed that traffic would continue to grow at pre-COVID rates. And when you put all of this into the dispersion model, the work that we did is represented in the graphic on the right-hand side, and all of the red markers indicate up to 15 units where we felt that there could be exceedances of the air quality standard for nitrogen dioxide. Now, local planning policy is quite clear. Openable windows are not allowed in areas where we have potential exceedances. So we're looking at sealed facades, not being able to open the windows even for purge ventilation purposes. So what we've managed to do on this occasion is to negotiate a planning condition which will allow us to continue to monitor after planning approval while the building structure is constructed. And what we hope is that by demonstrating that our assumptions have been overly conservative, we can introduce further levels of natural ventilation into the building design, and all of this will obviously help to meet our net zero carbon aspirations. Final slide, please, Andy. Okay, this is a second case study from the Claremont building in Newcastle-upon-Tyne. This is it's a grade 2 listed building refurbishment, looking to introduce greater levels of exhibition and recreational space on floors 1 and 2. The concern here was that the building is located just within the northern boundary of the proposed Newcastle and Gateshead clean air zone. And there was a concern that rat running around the edges of the clean air zone could be used as a strategy for avoiding charges, therefore pushing up traffic levels. So what we were able to do on this occasion, we were able to bring in some nitrogen dioxide monitors into the building, monitor NO2 concentrations at the facades, and demonstrate typical average levels of 26 micrograms per cubic metre, well below the 40 microgram per cubic metre standard. And on this occasion, irrespective of whether the clean air zone is implemented or not, we'll certainly be able to run with a natural ventilation strategy going forward. So I'd like to pass you on to Neil now, who's going to be focusing a little bit more on some of the transport-related issues of clean air zones. Thank you.
Cheers, Glenn, and thanks everybody. As we've been listening throughout this, clean air zones are going to have a wide-ranging impact on the city centre and the urban environments. And throughout the whole of this, people who mention the words traffic and transport. So for somebody who's in charge of a transportation team, I'm not going to say something controversial and say, well, actually, we shouldn't be talking about transportation any longer. We should be talking about movement. It's no longer all about transportation, and clean air zones will change our way of thinking into more of a movement-based design process rather than just transportation, because transportation tends to have the implications of traffic. So contrary to what you said there, the implications for transport in urban areas, the title of the first slide, but if you think about movement for in urban areas, as we know, the legislation environment's going to change. We're going to aid to help aid the achievement of objectives of the clean air zones. The internal combustion engine 2030 will be phased out, and that includes Euro classes, which currently some of the clean air zones can take Euro class 6 and 5s. That's going to have a massive implication to the design process for lots of reasons, which I'll come on to later on. Already, we need to look at our servicing strategies. This is a lot of public sector element of it, but vehicle fleet, smart technology. We're going to look at freight consolidation, reducing the amount of HGVs, reducing the amount of refuse vehicles on the streets. Just always thinking about how we reduce the implication of how we move. Parking, already we've seen in London. No parking at residential developments in city centres. London's already moved that, so we've to put an 860 unit development in London. There isn't a single residential parking space on it, with the exception of DDA compliancy. And again, I'll touch on that as we go through this. But also, we're not anti-car. We're here for the appropriate use of car, making people move correctly. So whilst we're talking about reducing car parking, there will still need to be car parking, because we do need to hold the car. People will still own cars, and so therefore EVCPs, electric vehicle charging points, will become more and more prevalent. And as Andy mentioned earlier on, there is a severe thought process, a very large thought process about how do we power those, what's the energy required needed those, and in some areas that may require new primary substations. It is as severe as that, and we need to be thinking about that in our design as we go forward. But also, mixed-use developments will become more prevalent. People don't need to travel as far in mixed-use developments. If you can live and work and play in the same place, you don't need to get into your vehicle to do that. So all these are immediate implications for transport. Again, as Jenny said, they're not a panacea, and there's unintended consequences. Andy Parkin's already nicked that phrase from me. Vehicle pollution is not simply tailpipe emissions. There are brake dust, there's engine wear, but also for clean air zones, there's the buildings, etc. So clean air zones are not a panacea. They will not, working on transport will not solve your problem alone. It is a large part of it, but you need to think of it as holistically. Access still needs to be maintained. We have a local economy, a nighttime economy, so access still needs to be maintained. So whilst again we're talking about vehicles, etc., and particularly reducing the amount of space required for these vehicles, we still need to make sure that local economies can be serviced, that people can park, that people can get to their house, but more importantly, mobility impaired. Lots of people forget about mobility impaired. They still need to have access, and we see all these designs coming in with flat surfaces, no curbs, etc., no tactiles. That needs to be thought about, because we cannot exclude those people. They need to be included in your designs. And again, I think as Glenn touched on there, social mobility. Those people who tend to require movement outside of sort of your traditional 9 to 5 tend to be in lower paid jobs, so your shift workers, your hospitality sector, etc. They probably will require a vehicle to get to their place of work, but actually not everybody can afford an electric vehicle. Not everybody can afford a Euro 6 vehicle. We have the rather stupid idea at the moment that actually if you can afford a high-level Porsche, you can get into the local low-emission zone in London. But yeah, if you can't afford to change your car and you've got a 12-year-old Ford Fiesta which you need to get to your job, you can't get into your low-emission zone, so you've got to pay the charge to get in. But actually, then what you need to think about is providing those people with alternatives. So when you're designing those your developments, your urban environment, you need to think what's the alternative to make sure that the clean air zone can be achieved. So public transport, cycling infrastructure, walking infrastructure, e-mobility hubs, all those need to be thought about. We're also changing online life. I think it was Andy Parker said, or somebody said, we're looking for working from home a lot more. And I think, as Jenny said, the HGVs have gone actually above levels of where we're of pre-COVID levels. Why? Because we're all sitting at home. Why? Because we're all having our Amazon Prime delivered. We need to think about how we live our lives. At the moment, do we actually need that parcel delivered immediately to my doorstep the next day, or can I actually wait till the end of the week and order 3 or 4 of them? So we need to think of deliveries, freight consolidation centres, electric vehicles coming in, etc. We just need to think of this holistically. So what are the design considerations? I appreciate we're running out of time, but hopefully we'll get through these quickly. So design considerations for transportation. Reallocation of road space. One of the biggest things, which, and I've done a previous seminar on this, a whole seminar, not at the moment, almost 35% of the urban environment is made up of road space. In fact, it's higher by the time you add on footways, footpaths, etc. A lot of that will not be required. So we can start to reallocate that, and that's where we can start to put in the infrastructure for other modes, for cycling, walking, e-mobility. As I said, clean air zones are not there to stop people travelling. In fact, they're there to make it more pleasant for people to move about a city centre. So we've got design for appropriate travel. We should not be designing, if we're having a city centre residential development, we should not be designing in bigger junctions, more road space, more parking, because actually most people will be able to do their journeys 2 to 5 kilometres. They can be easily walked, easily cycled, easily public transport. E-mobility is coming on, e-scooters. And we need to think about how we are designing our developments, how we're designing the urban environment to include these modes from the very start. Yet legislatively, we've had this in place for years. It's just we haven't had it enforced because the political will hasn't been there. So the political will is now there. Let's move it on. We need to think of delivery and service strategies. Smart bins, electric vehicles, freight consolidation zones, low emission vehicles. We have, I live in Edinburgh. One of the biggest things is during the festival, the bins are cleaned 4 to 5 times a day. That's a service vehicle, a big refuse vehicle, chunking out diesel, going through 4 or 5 times a day. If you have a smart bin with a sensor in it, if your service vehicle is only sent out when it's full. The public sector need to be thinking about changing, and private sector need to be changing their delivery vehicles to low emissions vehicles. Requires charging points again. Requires energy. So we need to bank that into the design process. DDA compliance. Don't forget about it. Everybody talks about no car parking spaces or no or limited access pedestrian zones. Well, actually, you need to think about DDA compliance. You need to think about those people who are mobility impaired. That needs to be put into your design process. You need to work your buildings so that people with mobility impairment can get out. Once they're out under the urban environment, they're able to move around. Andy Parkin talked about noise, and electric vehicles are horrendous for those who are sight impaired. And we are going to get vehicles now putting in false noise, putting in them. So we just need to always think about who's using the environment, what are the aims of clean air zone, and why are we trying to do this. So the way forward for designing clean air zones, it's not all about transport. It's not all about noise. It's not all about air quality. Yes, they may be the biggest impacts, and they may be the intended consequence. We need joined up thinking, everybody in the urban environment. One of the biggest bugbears of transport planners and people who work in my sector is greater interaction with land use planning. Andy Parkin mentioned earlier on, you have a clean air zone. Well, then you create a shatter zone at the edge of it, of that clean air zone, where everybody goes, drives, dumps their car and puts in. Poor people who live in those shatter zones. So we need to think more about how land use is used, not just where your development is, but actually what's the implication further away. Be bold. Be willing to accept that the norm has changed. Don't just think, oh, it's a clean air zone. Oh, I'll stick a few electric vehicle charging points in. That'll do. Oh yeah, I'll make sure that the urban environment change so that it's better for electric vehicles. Yeah, that's fine. Be bold. Change everything. Change the way you're thinking. Change how the whole life cycle of your development. Look to the future. That's part of being bold. Smart transport and smart movement is the future. People will not own cars as much in the future. Mobility will become a service. E-mobility. You'll get on your e-scooter, your e-bike. Apps. Site-wide apps. Because if you're a developer or a local authority putting a big master plan, let's make sure an app is for that master plan, so you know where the best way to get your local sandwich shop. You can order a cargo bike delivery of your Amazon Prime order, Amazon order, which just sits on the outskirts and delivered to it. But I think most importantly, and it goes back to the very first comment I had here, which is no longer transport, it's movement. Be prepared to reduce the decades-long dominance of the private car. Be brave. Think of things as movement and no longer think of things as transport in the private car. And hopefully I've clawed back some time, and I'm going to pass on to back to Andy Parkin now for some closing thoughts.
Okay, well, thanks everyone. I think the overriding message from all of what we've talked about is that this is a really complex issue. As soon as we start affecting one aspect of our urban environments, everything else there are ripple effects that everything else has to look at. And as Neil says, we can't deal with any of these in isolation. It has to be a joined up approach. Otherwise, we end up having a real Frankenstein's monster of a design. So get the designers involved early, look at things holistically and look at things sustainably, and we'll get the right solutions. So just some takeaways from what we've talked about. We need to carry on monitoring. We can make predictions. We can look further down the line and think we know how things might be, but let's constantly reevaluate that. Measure air quality, measure noise, and readjust our strategies as needed. Generally, the noise implications of clean air zones should be net positive. But there will be knock-on implications. I think Neil called them shatter zones, those ones who bear the brunt when the traffic goes somewhere else instead. But generally, when the transport stock decarbonises, then the overall noise should reduce. But as long as it's not raining, and it never rains in the UK, so that's fine. And think beyond electric vehicles. Think bold. Think big. Think different. And think about movement rather than transport, and then we'll change the way that we think. So thank you everyone for your attendance. Thank you for holding on, and there are time for some questions if anyone has any.
We've got a few in, I think. Depending on how many we get through, depends on how long the answers are. So bear that in mind, guys. I'll just chuck them out and then you can decide who's best to answer them. So the move to electric and non-internal combustion engine fueled road vehicles will inevitably result in huge financial loss to the Treasury and fuel duty in VED. Is it likely that a pay per mile for all vehicles or similar road use charge scheme may be introduced to compensate for this financial loss rather than the current polluter pays system?
I'll go first, and then I'll pass over to somebody else. Trust me, the Treasury will not lose out. The Treasury will find a way to get your money back, and already we're seeing VD. It's an extra £400 if your vehicle's over £40,000 per year for 4 years. Most electric vehicles fall into that category. So they will find ways of doing it. But back to the road charging and road pricing. That argument's been around for years, and actually the economics of it have never seemed to stack up. Because what you're essentially trying to do is make people mode shift. And as soon as the road pricing becomes effective and they've mode shift, you've lost your revenue stream. So then what do? Do you start taxing public transport? So I suspect what will happen is that VED will move away from the emissions-based model and will essentially go to a price-based model, and will be hit with a larger tax, if you want, when you buy your vehicle, or as is currently the case, when you buy your vehicle, and then for the next 3 or 4 years after that, you'll be hit by a larger tax and implications. And I'm sure somebody else might want to add to that. Or maybe not.
Nice short answer, thank you. You mentioned that the monitoring will have a key role to play, yet in itself it can be impacted by the sources of error and uncertainty. How do you ensure that the accuracy of monitoring results is adequate and that the quality of data is fit for purpose?
Okay, yeah, that's probably one for me to take. Yeah, the various monitoring techniques that we can use can range from cheap and cheerful, with obviously higher levels of inaccuracy, to kind of really expensive, top of the range instrumentation where we have much greater levels of accuracy. So we're mindful of the limitations of the different monitoring techniques that we use. When we've got cheaper, more inaccurate monitorers, often we can co-locate them in triplicate to try and improve the accuracy of our measurement. And with a lot of our sensors, some of them can be used indoors and outdoors. So we can co-locate them with council monitors prior to undertaking the work. And then obviously those are all traceable to national standards, and we can link the results from our indoor air quality monitoring to kind of other methods with much greater levels of accuracy. And I think it's always important to bear in mind the limitations of the equipment that you are using when you draw your final conclusions. So for instance, the Claremont building monitoring was done with a mid kind of cost range sensor. But obviously, with levels so far below the air quality standard, we can be reasonably confident of our predictions in cases like that. Where we're closer to the standards, we need to either use higher quality instrumentation or carry out monitoring for longer periods.
Okay, anyone got anything to add on that? All good? And then because I'm quite interested in this one as well. I don't know if any of you are going to be able to answer it, but has any modelling been undertaken on CAS and how it reduced the need for cleaning facades? The image that you showed of the Claremont building in Newcastle appeared to accumulate a significant amount of dirt.
Yeah, I'm happy to take that one again. The data that we've seen, we can obviously predict tonnage reductions of material empirically. I haven't seen any kind of further work on this, but technically, yes, it would be possible to take that data on a few levels and to try and work out the kind of impacts at buildings and building facades. But I haven't certainly read any research or work where that has been carried out in that particular application.
Okay, thank you very much. I think we are
just one thing that came to my mind as we were going through, Helen. One thing that Neil mentioned is about the number of mixed-use developments increasing, and I think that's something that we're seeing. The high street has changed, not just because of COVID, but because of the advent of online. And I think what we've seen during COVID is probably an acceleration of what we would have got to anyway. but there'll be a lot more developments which are mixed use. A lot of shopping centres will no longer be able to support all shops. They'll have residential in there, they'll have leisure as well. And so there will be more self-contained developments, either in the city centres or the peripheries, as the experience economy becomes more prevalent. And therefore that will probably help fuel a lot of this this shift change in the way that things are happening.
Sounds like another webinar to me.
Can I just ask one question? Apologies, I'm hijacking and people want to go away, and that's the Andy parking.
Oh, thanks.
It's a pleasure. And I haven't teed this up, guys. I do promise that. And you mentioned that, and I've mentioned as well, that vehicles will put in false noise of electric vehicles, potentially for those people with sight impairment, potentially hearing impairment, etc. mobility. Is there any type of false noise which can be put into vehicles which actually has less impact on the design in the urban environment, or is it literally we're going to get people wanting to hear a Ferrari coming down the road when they're driving a Vauxhall Corsa?
Yeah, I mean, it's quite an emotive thing, really, and there's been a lot of research done about this. I mean, some people have been playing around with making electric vehicles have the sound of TIE fighters from Star Wars. I think one research paper showed that a duck quacking was the least disruptive noise from an electric vehicle. It all seems a bit bonkers, really, and I don't know what the outcome is going to be, but it just needs to be looked at sensibly and in context as well, because what we don't want to be doing is introducing a whole out of context load of noise into a city centre when we're just changing one problem and causing another.
Fair enough.
How I'd feel about ducks driving down there.
Yeah.
Anyway.
And also what we don't want is people to start honking the horns instead, because that's far more disruptive to people living in the area than engine noise.
Well, thank you very much, everyone, for your time. We've just hit that hour, so we'll leave you all to get on with your day. Obviously, if you do have any questions, please feel free to either email them to me and I can forward them on, or forward them to the speakers directly. All the details will be in the first invite that we sent out. But other than that, again, thank you very much.
Thanks, everyone.
Thank you.
Thank you.